Welcome to Task 1. Create a detailed list of design specifications and justify your choice. Let's roll the intro. Hi everyone, and welcome to Task 1, Develop Your Design Specifications. What we're doing today is that we are checking into your Unit 1, Task B1, Design Specifications, and build your build the box activity. I'm going to explain in detail how you can get the best type of design specifications. And I'm using the website. So if you go to our ISM design website, website that I've created for you guys, there in Criterion B, we open it up and it's the design brief task. And this is exactly what we're going to do today. Now, let me open it up for you so that you can see what it's all about. So how are we getting this list done? Number one thing is that the specifications can be divided into two categories: constraints and considerations. Now, when you start thinking about, well, what should my design specification brief look like? Well, it is going to be an A4 table. Something like this here on your slide. Now, the constraints are some things that you cannot change, and the considerations are elements of design that must be thought about. Now, you will have limitations or essential requirements for your design. That's the problem, right? But for considerations, you have multiple solutions, and it's up to the designer to find the optimum solution. And what I have done and created for you is that you got these tips and tools where you get to use your design brief to develop your specification. You need to be as specific as possible, consider how the specifications will be tested, and then you're going to write your B1 design specifications. Now, you might consider writing your D1, which is the testing of your design, together, because this way you can ensure that your specifications are related to the brief and can be tested. When you are writing, and now let me put this one in full screen. So when you are writing, be concise and specific in your writing. Organize your statements using the following formula: statement, connector, justification, or an example. Connectors are words that connect, like therefore, so, however, thus, in order to. You also might want to consider using could, must, may, or should to soften sometimes your statements. Here are some examples. The portable laptop stand must be assembled in 30 seconds without special tools in order to meet the user's need for quick assembly. The device should use renewable solar energy in order to reduce the environmental impact of its use. Therefore, it should have a place for solar panels to be attached. So this way, you are making a statement, connecting it, and justifying its use. Your design specification might, depending on your inquiry, use performance considerations. Here are some good examples. Pay attention to this. All the equipment necessary for controlling the greenhouse and the growing plant's needs to fit in or on the design in some way. This would include systems for holding plants and water, as well as space for the Arduino controller, LED lights, power supply, and cabling. A poor example would be it must be easy to use, without explanation and justification. I have added good examples of each of the categories that you might want to use for your design specification. Finally, when you are reviewing your specifications, you should do that with a partner, so that you get a feedback. Are the specifications specific? Can they be measured? Is the type of data to gather going to be accurate, useful, and meaningful to you? If the evaluation involves a survey, are the survey questions listed? Are the questions only closed questions, yes and no questions, or are there also open, thick questions to allow for user opinion? Are the specifications about the product that are not being tested? Should they be? Avoid these words: nice, convenient, easy, or simple. What do you mean by nice? How is the product convenient? So when you work with this, you are then ready for build the box activity. This activity helps you to develop your constraints so that you can then develop your idea. The constraints define what a solution should do. The designers use constraints to guide their thinking and to understand what a successful solution looks like. Here is an example of the tool that I was using. I had materials, users, aesthetics, cost, time, dimension, or other environmental issues, and then, of course, the performance. And here is an example of how it can be used. So once you have used your whole circle, all four sides, you are ready to fill your design specification. During this lesson, please make sure that you are contacting me via Google Chat, Google Meet, or email. If you are present in the classroom, then please come and see me at the help desk. Have a great lesson.